CAPTCHAs and IP bans are the two most common obstacles in any scraping operation, automation, or multi-account workflow. Most people think the solution is just swap your IP and try again. But that's not actually how detection systems work. This video explains the actual mechanics behind why CAPTCHAs happen, why they don't always go away when you change proxies, and where mobile proxies actually help versus where they don't. Let me start with something that might surprise you. A lot of operators say I'm using mobile proxies but I'm still getting CAPTCHAs. The reason is they're missing an entire layer that has nothing to do with the IP itself. And that's what I want to focus on in this video. So how do CAPTCHAs and IP bans actually work? They're not random. They're the output of trust scoring systems that evaluate incoming traffic against a specific set of signals. When a request scores below the threshold for likely human, the system responds with friction. Either a CAPTCHA challenge to verify you're human or an outright block if the score is low enough. These scoring systems look at three main categories of signals. First, network signals. IP address, the ASN. That's the network the IP belongs to. IP reputation history. Whether the IP is on any block lists, geolocation consistency. Second, browser and device signals. User agent string, browser fingerprint. We're talking canvas rendering, WebGL output, installed fonts, screen resolution. TLS fingerprint, HTTP2 settings, header ordering. Third, behavioral signals. Request timing, action sequence, mouse movement patterns, scroll behavior, how long sessions last, request frequency. Each of these contributes to a composite score. And here's the key. No single signal triggers a CAPTCHA on its own in most modern systems. It's the combination of signals that determines whether you get challenged. This is why the relationship between proxies and CAPTCHAs is more nuanced than most guides suggest. Mobile proxies help with one specific layer. They don't help with the others. Let me explain where mobile proxies do help, which is the network signal layer. The ASN of your IP is one of the first things a detection system checks. ASNs from cloud hosting providers, AWS, Google Cloud, DigitalOcean, Hetzner, those are immediately flagged as non-consumer traffic. No real user browsers from an AWS data center. But ASNs from mobile carriers, Singtel, T-Mobile, Vodafone, SoftBank, those are treated completely differently. They are the same networks serving millions of real smartphone users every single day. When your request arrives from a mobile carrier ASN, the network signal layer starts in a high-trust state. The detection system has to rely much more heavily on the other layers, browser signals and behavioral signals, to decide whether to challenge you. That's the core mechanism why mobile proxies generate fewer CAPTCHAs than data center proxies on the same target. There's also the NAT mechanism. Mobile carrier networks use NAT extensively. That's network address translation. Thousands of real devices simultaneously share the same IP ranges. This creates a constraint for detection systems. They literally cannot aggressively block mobile carrier IP ranges without blocking enormous numbers of legitimate users. So there's higher tolerance for mobile carrier IPs. A request volume that would trigger a block from a residential IP or an immediate ban from a data center IP often passes without challenge from a mobile carrier IP, because the platform knows that same IP range is being used by tens of thousands of real people. And finally, clean IP reputation. Data center and residential proxy pools are shared across many users. If a previous user abused an IP, hit rate limits, triggered bans, sent spam, that history follows the IP. When you get assigned it, you inherit that reputation score. Mobile carrier IPs refresh more often naturally, and a good provider ensures they're not recycling IPs in ways that accumulate negative history. The starting reputation of a clean mobile carrier IP is typically better than a recycled data center or residential IP. Now here's the critical part that most guides skip. This is why people still get CAPTCHAs despite using mobile proxies. Mobile proxies don't do anything for browser fingerprint signals. A mobile carrier IP sending requests from a browser with a data center typical fingerprint creates this inconsistency that detection systems flag immediately. The network says mobile carrier in Singapore, but the browser fingerprint says headless Chrome on Linux. That mismatch is more suspicious than a consistent data center setup. Modern detection systems, Cloudflare, Akamai, Datadome, Perimeter X, they fingerprint the browser at a deep level. They are looking at canvas and WebGL rendering signatures, audio context fingerprints, font enumeration, navigator properties like plugins and MIME types, hardware concurrency. They check TLS fingerprints, cipher suites, extensions ordering, HTTP 2 settings fingerprints, timing of DOM events. A mobile proxy cannot fix any of this. If you're running headless Chrome with default settings through a mobile proxy, you're presenting a mobile carrier IP with a bot-typical fingerprint. The IP trust helps at the network layer, but the fingerprint layer completely undermines it. The fix for this is a properly configured anti-detect browser, something like multi-login, go-login, or AdsPower that generates realistic, consistent browser fingerprints. Or a properly configured scraping framework that actually spoofs TLS and HTTP2 fingerprints to match real browser behavior. And then there's the behavioral layer. Even with a perfect IP and a convincing browser fingerprint, robotic behavior patterns trigger challenges. Detection systems look for mechanical timing, requests arriving at perfectly regular intervals, impossible speed, page loaded, form filled, submitted in 200 milliseconds, missing interaction signals, no mouse movement, no scroll events before an action. They look for identical action sequences repeated across sessions. Real users misclick. Real users hesitate and correct themselves. Bots don't. A mobile carrier IP does not humanize robotic behavior. If your automation script clicks a button 50 milliseconds after page load every single time, the behavioral signal layer will flag it. It doesn't matter how trusted the IP is. The fix here is randomized timing, realistic interaction simulation, and for account-based work, genuinely human-like session patterns rather than scripted sequences. So the reality is you need all three layers to pass simultaneously. Think of it as a composite score. High trust on all three layers keeps the score above the challenge threshold. Weakness on any one layer can drag the composite score below it, regardless of how well the other two perform. Here's the practical framework. Network layer. You want a mobile carrier IP or a residential IP for lower sensitivity targets. Clean ASN, no block list history, appropriate geolocation. Browser and device layer. Realistic, consistent browser fingerprint. TLS and HTTP2 fingerprints matching real browser behavior. Headers in the correct order with correct values. Behavioral layer. Human-like timing variance. Realistic interaction patterns, appropriate session lengths, no mechanical repetition. Mobile proxies solve the first layer well. They don't touch the second or third. The operators who cover all three layers consistently report dramatically fewer CAPTCHAs and near zero IP bans compared to those who only address the network layer. Different platforms weight these layers differently though, which is why the same setup can work on one target and fail on another. Cloudflare relies heavily on browser fingerprint and TLS fingerprint. It's relatively less dependent on IP reputation for the initial CAPTCHA decision. A mobile carrier IP with a realistic browser fingerprint usually passes Cloudflare's passive challenges without triggering an interactive CAPTCHA. But a headless browser with a mobile carrier IP will usually still get challenged. Google reCAPTCHA v3 uses a behavioral scoring model from 0.0 to 1.0 that weighs all three layers. IP reputation is one input, but behavioral signals carry significant weight. Mobile carrier IPs improve the network component, but they don't automatically produce a high score without realistic behavior. Platforms like Shopee, Lazada, and other Southeast Asian e-commerce platforms use custom detection tuned for their user demographics. Their expected traffic is heavily mobile from C carrier networks. A Singapore mobile carrier IP is genuinely expected traffic for Shopee Singapore. The network signal layer passes almost automatically. The remaining friction comes from browser fingerprint and request patterns. Social media platforms run the most sophisticated detection of any consumer platform. They evaluate all three layers, plus additional signals like account history, device consistency over time, interaction pattern evolution, and social graph signals. Mobile carrier IPs are necessary but far from sufficient. The behavioral layer is extremely important. So how do you set this up to reduce CAPTCHAs across all three layers? Network layer setup. Use a mobile proxy provider with genuine SIM cards on carrier networks, not data center IPs labeled as mobile. Match the proxy geography to the target platform's expected user base. If you're scraping Shopee Singapore, use a Singapore carrier IP. For account-based work, use sticky sessions so the IP doesn't change mid-session, browser and device layer setup. For account-based work, use an anti-detect browser with a realistic, stable browser profile per account. For scraping, use a scraping framework that properly handles TLS fingerprinting rather than stock puppeteer with default settings. Make sure your user agent strings match your actual browser fingerprint. Chrome 120 user agent with Firefox TLS fingerprint is immediately inconsistent. Behavioral layer setup. Add timing variants to all automated actions. No two requests should arrive at the exact same interval. Include realistic pre-action delays like scroll, hover, pause before click for platforms that monitor interaction events. Vary session patterns across different accounts. Don't run identical action sequences on multiple accounts simultaneously. For account warming, start with low volume, organic seeming interactions before moving to higher volume. Now there's a specific configuration that directly reduces CAPTCHAs for account-based workflows, and that's sticky sessions. When the proxy rotates mid-session, the platform sees a session that started from IP and continued from IPB. The inconsistency is itself a detection signal. It looks like a session handoff, credential theft, account sharing, or someone switching proxies mid-operation. The platform responds with a challenge. Sticky sessions prevent this by maintaining the same IP for the full session duration. The platform sees a consistent IP from login through all actions, which matches the expected behavior of a real user on their phone. No mid-session IP change, no challenge trigger from that signal. I actually covered sticky sessions in detail in another video, so check that out if you want the full breakdown. Here's something important though. There's a category of CAPTCHA problem that proxy selection can't fix. If an account has been flagged at the account level due to previous suspicious activity, reports from other users, policy violations, or risk scoring from historical behavior, the platform will challenge that account regardless of IP quality. A CAPTCHA in that situation isn't a proxy problem, it's an account trust problem. Similarly, CAPTCHAs during account creation are heavily influenced by account age and warm-up history, not just the IP. A brand new account with a clean mobile carrier IP will still encounter more friction than a 6-month-old account with an older residential IP because there's no trust history to evaluate. Understanding whether a CAPTCHA is a network problem, a fingerprint problem, a behavioral problem, or an account trust problem determines the correct fix. Changing proxies when the problem is account trust is just wasting money and time. Let me hit some common questions people ask. Do mobile proxies completely eliminate CAPTCHAs? No. Mobile proxies significantly reduce CAPTCHAs caused by poor IP reputation and data center ASN detection, but they don't address browser fingerprint or behavioral detection. On platforms with multi-layer detection like Cloudflare or social media, CAPTCHAs can still appear if the other layers aren't also addressed. Why am I getting CAPTCHAs with a mobile proxy when I wasn't before? A few possibilities. The target site updated its detection system. Cloudflare updates constantly. The specific mobile IP you're using has accumulated negative history from other users. Or a recent change in your setup introduced a fingerprint inconsistency. Check whether the CAPTCHA appears immediately. That's network or fingerprint issue. Or after some interaction. The timing gives you a clue about which layer is triggering it. Are mobile proxies worth the cost for CAPTCHA reduction? For targets where the primary detection layer is IP-based, Southeast Asian, e-commerce, some content platforms, yes. The reduction in friction often justifies the cost difference over residential proxies. For targets with sophisticated multi-layer detection like social media or major financial platforms, mobile proxies are necessary, but not the complete solution. The bottom line here is that mobile proxies reduce CAPTCHAs and IP bands by improving the network signal layer. They provide carrier-grade ASN trust, benefit from the tolerance built around shared mobile net, and start with cleaner IP reputation than data center or recycled residential alternatives. But they don't fix browser fingerprint signals, they don't fix behavioral patterns, and they can't resolve account-level trust problems that exist independent of the current IP. The operators who consistently avoid CAPTCHAs treat it as a 3-layer problem. Mobile proxies handle 1 layer well. The other 2 require separate attention. But when
benefits and challenges. This framework is what you need to understand. Check out the full guides on the website for specific implementation details. For a complete multi-layer setup, head to dataresearchtools.com. And if this video helped you understand the 3-layer detection model, subscribe for more deep dives into how these systems actually work. Next video, I'm covering IP rotation and when to use it versus when it actually makes your problems worse. See you there.